Right, hi everybody. Welcome to the 7th. Well, okay. Today is the 7th of December. I haven't done Advent of Code over the weekend just because family and things. So what I'm going to try and do today is I'm going to try and do the last three challenges, right? The 5th, 6th, and then today is the 7th. I've no idea whether I'm going to get through it fast enough. I don't want to spend forever doing this. So maybe if I don't get there, I might slip the timings a bit as we work through this. Through the weekend I have had a peek at the different challenges just to try and start thinking about things in my head of how am I going to approach this, slightly in an effort to just speed things up. Part of the point here is I'm trying to solve the Advent of Code challenges using as much GPU compute as possible and doing as much on the GPU and as little on the CPU. I don't really care about time, I don't really care about that kind of thing, but I am going to try and go fast today. So you know, apologies if I skip through. If you head to the link that's down the bottom there, it will take you through to this Git repo where you can see a bunch of like standard questions about what I'm doing and how I'm set up and how I'm writing my code and how you can find probably better, more informed solutions than what I'm working on. But yeah, so let's jump straight in to Advent of Code day 5. Yes, so Saturday. You board your plane only to discover a new problem. You dropped your boarding pass. You aren't sure which seat is yours, and all the flight attendants are busy with the flood of people that suddenly make it through passport control. You write a quick program using your phone's camera to scan all the nearby boarding passes, which is the puzzle input. Perhaps you can find your seat through the process of elimination. Instead of zones or groups, this airline uses binary space partitioning to seat people. A seat might be specified like a string of F, B's, and L's and R's, where F means front, B means back, L means left, and R means right. First 7 characters will either be F or B. These specify exactly one of the 128 rows on the plane, numbered 0 through 127. Each letter tells you which half of the region the given seat is in. You start with the whole list, 0 through 127. The first letter indicates whether the seat is in the front half or the back half, right? So it's either 0 to 63 or 64 through 127. The next letter indicates which half of the region the seat is. The next letter indicates which half of that region the seat's in, and so on until you're left with exactly one row, right? So you're cutting in half every time. It's a bit like a binary search. For example, consider these first 7 characters. Okay, so it's kind of stepping us through and saying, right, we start with 0 through 127. We get an F, so that is the lower half, so we cut it at the lower half. Then we get B, which we want the upper half of what we have left. So we get 32 through 63. And then F, we're cutting in half the lower half of this, this range. So we end up with 47. And then we're going to cut this in half and take the upper half. So this becomes 40, etc. And we keep bouncing around until we finally get to row 44. The last 3 characters will be either L or R. They specify exactly one of the 8 columns of the seats on the plane, numbered 0 through 7. Same process as above proceeds again, this time with only 3 steps. Left means lower half, R means upper half. So for example, you have your last 3 characters R, L, R. You have 0 through 7. R is the upper half, so we end up with 4 through 7. And L, the lower half of that, so we end 4 through 5. And then R gives us column 5. So decoding this tells us that we're row 44, column 5. Every seat also has a unique seat ID. Multiply the row by 8, so 44 by 8, and then add the column. In this example, it would be 44 by 8 plus 5 is 357. That's the seat ID. Here are some boarding passes and their seat IDs. Lovely. As a sanity check, look through your list of boarding passes and what is the highest ID. Right. Okay, so the way that I was thinking about doing this is we can map through the list of inputs, which is fine. And what we should do, we're going to have these. We're going to have a list of these numbers, right? Let's make some folders. Let's not skip ahead, right? So the 5th. Yeah, let's make ourselves a new notebook and call it solution. And we'll have a new file and call it input. Let's grab our day 5 input here. Just copy that. As we can see, this is like a nicely regular array, right? We've got how many rows? 743 rows. And there's exactly how many columns there are. 10? Is it 10 columns? Yeah, first 7 characters and the last 3 characters. So there's 10 columns. So we can easily convert this into an array. If we read this in, we've got a nice array. And then on our GPU, we'll map over the rows, and then we'll calculate each row like independently with a bit of logic. And then if we have an output array which is the same length, which will contain the numbers, and then we can call max on that. So let's start right at the beginning. Let's do like data like reading. I don't know what to call, never know what to call this. Our like ETL section, I guess. Which will say with open input.text as fh, and then do we want to read our rows. Let's start with let's have our like let's call this tickets, and let's start with the list comprehension. So we'll say row dot grip for row in fh.read lines. Okay, so this will give us a list of each row as strings. Now let's input numpy because we want this as an array. So we do np.as array. Why I didn't complete there? As array as np, and have a look at tickets come out of this. So that gives us an array of these strings. But then we said we wanted like a 2D array, so we want to also this row.strip. Let's put that in a list comprehension as well, and we can do, you know, character for character in row.strip, and this should also be a numpy array. Let's go like that. Okay, so we've got our 2D array. But this is a 2D array of strings, which we don't really want, because we found on day 2, 3, something like that. If you go back through the solutions, we were struggling to do string processing on the GPU with number. I'm going to use number for this. You know, number is called number. It deals with numbers. So let's convert this to number using odd. So now we've got a numpy array of integers here, where these are their, I guess, Unicode positions or ASCII positions or something. So this is our tickets, our input. Now we're going to need to do some comparisons right in here. We're going to need to say, you know, if it's this, I guess is, we've got F and B, haven't we? So this will be F, this will be B, this will be B, and this will be R, this will be L. So let's have like another array. This will be like our comparisons is going to be, let's call it np.asArray. And then let's have odd of character, I can't type, odd of character for character in, and then it was front, back, left, right. Yeah, because front, F is lower half, B is upper half, right? We've got front, back, left, right. So we've also now got another array. Yeah, that should be normal brackets. Okay, so we've got our little comparisons array here as well. So we can now unpack this and then say, oh, is this equal to that or whatever. Now I'm just going to copy some code from like a previous day just to get the structure. Probably not day 4 because I think we used QDF on that day. Look here, yeah, let's do from number import CUDA, and let's just take these. Okay, so we've got our data. Just pause for a second. We've got our data in our format that we want it in. So now we're going to do part 1. Let's call this part 1. So from number import CUDA, let's have a function, and this will be our calculate ticket numbers, and it will take in tickets. Oh god, I really can't type tickets. And it will take in our comparisons, and it will also take in our, we'll have an output array as well. array. So let's make that 2. We'll call that output equals np dot zeros, and then it will be if I do length on tickets, is that going to give me the right thing? Yeah, 743. So we'll have an array of zeros that's the same length as our tickets, right? So we'll have those things. Calculate ticket numbers. So then we want our position is our absolute grid position, and we want to make sure height is length of tickets. Length of tickets. And then here we'll put our calculate ticket number logic, right? For now, let's just make our output at position equal to 1, just to make sure that we are correctly running our code. Now let's do our threads per block and all of that. Copy that from here. This will be our length of tickets. The length of tickets there. So we can then do something like, oh yeah, that's a good idea. Do this. Let's put our output here and then have a look at the output. So it resets every time we call it, basically. We're going to calculate ticket numbers. We're going to give it tickets because it's expecting that. We're going to give it comparisons. Oh no. Ooh. Tickets, comparisons, and output. Let's run that. We should get a bunch of 1s. Yes, good. Okay. That's what we want. So now I need to do the ticket number logic. So I think what we want to do first is we want to split out our comparisons. So what do? We did front, back, left, and right. It's going to equal our comparisons. So we're going to break our array apart, basically. Make sure we still can run that. That's good. And then we can calculate our numbers. So we want to do something. I might just do this in pure Python for a second, just so we can have a look at it. So let's do a little down here. We do for what are these called? Let's just do for I in range 7. Because that's how many times we're going to go through this, and we're going to have let's take their example, right? They've got this example here. We have our let's also grab our thing here. So we're going to have our instructions is going to be tickets position. Let's also just copy that down here. So we'll do we'll have instructions equal let's just do that. So instructions is going to be that, right, which is our row array. And then we're going to go for, I can probably just do for I in instructions. And then I should probably do a comparison. We've got our comparisons already. I might just split those out as well, like this. Run back, left and right equals our comparisons. And then we'll say if I equals front, print front, back, left, right, back, left, right. Run this. We got a set of instructions front, back, front, back, back, front, right, left, right. Okay. Then we're going to need to do, we'll have lower and upper is 0 to 127. Yeah, 0 to 127. So if we say front, it will be Y lower. Or should we put it row lower? Row lower, row upper, and then we'll have col lower and col upper, and that was 0 through 7. Then if I is front, we want to do row lower, if it's the front, have a look at this. If we get F, it means we take the lower half, which means the bigger half gets smaller. Okay, so row upper equals, and it'll be like the average of them, right? So we row that plus row upper. I think to get 63, it needs to be upper minus 1. Row upper minus 1. Okay. That plus that divided by 2. Okay. And then for back, the upper half. So we have 0 through 63, and we want the upper half of this. So this lower number is going to become the average of these two. But this would be plus 1. We wrote lower, that does that. And then for left and right, we're going to do the same thing, right? So R means to take the upper half. Wrong way. So the lower would move. Col lower is going to be col lower plus col upper. That. And then front and back. Change those to col lower, col upper. And then we should probably, let's have a look at what these come out as. So let's do col lower. Oh yeah, let's have a look at all these numbers, see what happens. That gives us 44 and 5, which this answer was 44 and 5. Good. And then, so the answer is going to be, let's just work with the lowers. So we want to say row lower is row, wasn't it? Is multiplied by 8? Yeah, row times 8. Row times 8 plus column. Gives us 357, which is this answer here, 357. Because this one is 567. 567, and this one is 119. 119. Okay, that works. I'm literally just going to take this logic into here, like that. We're going to set our output position equal to that output there. That needs to be at the top here. That doesn't need to be in because we've already got it. That's number 1 floating around. That should be everything. Okay. We followed that logic. We've run that now on everything because our instructions we're just pulling out at that. And we're putting it back into the array with these answers. So we've got our output array. And then it said, look through your list. What is the highest seat ID? So we can just do max on output. Max on output. So that's 838. 838. Right answer. You got a gold star. Fantastic. Right. Part 2. Ding, the fasten seatbelt signs have turned on. Time to find your seat. It's a completely full flight, so your seat should be the only missing boarding pass on the list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft. that we're missing from your list as well. Your seat wasn't at the very front or back though. The seats with IDs +1 and -1 from yours will be in your list. Okay, what is your seat? So of this list now, we want to find the missing number, don't we? That's fun. But we want to... There are a few missing numbers, but we want to find ones where there is only one missing seat in a row, right? I wonder if we could do like sorted output. Yep. And then let's do for seat in sorted output. I think this is probably going to end up being a little CPU thing just to get us through there. For seat in sorted output, if seat -1 in output and seat +1 in output. No, wait. We want the missing values, don't we? We almost want to like invert this list. Okay, let's do this. Let's say all seats equals mp.arrange one hour in arrange. Yeah, start, stop, step. Right, so this will be min output, max output. Right, that's going to give us all of our possible seats, right? All seats. Okay, so all seats is this list. So we want if, yeah, and then we'll do for seat in all seats. That actually needs to sort of do. For seat in all seats, if seat -1 in output and seat +1 in output and seat not in output, print seat 714. Okay, so just to be clear what we've done, we've like made a new array. I should call this day 2, part 2, shouldn't I? Part 2. We made a new array that covers the whole range, and then we've just gone through each seat and said if the seat -1 is in the output and seat the +1 is in the output, but the seat isn't, it might be more readable if I just swap this around. Actually, if I say if the seat is not in the output and the ones either side and +1 and -1 are in the output, then print it. So that's 714. 714. Submit. Right answer, 1 gold star. Return to your advent calendar. Fantastic. Okay, so 1 day done. 20 minutes. Fine. Let's keep going. Let's keep going and see where we get to. So let's move on to day 6. Customs. As your flight approaches the regional airport where you switch to a much larger plane, customs declaration forms are distributed to the passengers. The form asks a series of 26 yes or no questions marked A through Z. All you need to do is identify the questions for which anyone in your group answers yes. Since your group is just you, this doesn't take very long. However, the person sitting next to you seems to be experiencing a language barrier and asks if you can help. For each of the people in their group, you write down the questions for which they answer yes, 1 per line. For example, A, B, C, X, A, B, C, Y, A, B, C, Z. In this group, there are 6 questions to which anybody answered yes. A, B, C, X, Y, and Z. Duplicate answers to the same question don't count extra. Each question counts at most once. Another group asks for your help, then another. Eventually, you've collected answers from every group on the plane, which is your puzzle input. Each group's answers are separated by a blank line, and within each group, each person's answers are on a single line. For example, here's some input. This list represents answers from 5 groups. The first group contains one person who answered yes to 3 questions, A, B, and C. The second group contains 3 people. They answered A, B, and C, so they are also A, B, and C. The third group contains 2 people combined. They answered yes to 3 questions again, because we've got A, B, and AC, so we've got duplicate A, but we've got all of those. The fourth group contains 4 people, but they all only answered yes to A. And the last group contains 1 person who answered yes to only 1 question, B. In this example, the sum of these counts is 11. Okay. For each group, count the number of questions to which anyone answered yes. What is the sum of those counts? Right, fine. Let's move up to day 6 then. Go 6. Have new notebooks for these. Rename this. Having these tabs open, I feel like I should maybe give them unique names, but I don't want to fold it. New file, rename input.txt. Okay, so I'm going to move that there just to try and make this. Yeah, I think I might go through these notebooks and add some better names and some titles and things, but let's just say markdown. This is going to be day 6. Read input. I feel like I change the name for this every time. We've got our input. Let's go and grab that from here. Get your puzzle input. Copy everything, paste into here. Fine. We did something like this before where we did when I read this over the weekend, I was kind of thinking this one I probably are going to end up encapsulating most of the logic here in the reading. You see as we go, I think. What we want is the list of groups, right? So with open input file, we want our groups is equal to a list like this, and then we want to do we want like our group here is also going to be a list like this. Or we call this group answers. A-N-S-W-E-R-S. I just cannot type. Group answers equals nothing as well. And then we'll do for row in fh.readlines. Row equals row dot strip. So we want to do if row is blank. We want to wonder whether the other day I had a problem with my logic because I deleted the final blank line from the end of the file. I think I'm going to put that back in. So if row is blank, we're going to do groups.append. Now I'm planning on this group answers to be a list of each thing they've answered. So for this, let's go with this third person, right? Oh yeah, the first person, we're going to have a list of A, B, and C. And the next one will be a list of A, B, and C. And then the next one will be a list of A, B, A, and C. Right? So we end up with a duplicate in group answers, which is fine. But what I want to do is append a set of the group answers to there. So this will just be a list of like the unique answers for each group. And then continue. Otherwise, we're going to do group answers equals group answers dot append. Oh no, I probably want to do actually plus equals row dot split row dot split on nothing. And then let's have a look at groups at the end of this. Empty separator. What have I done? Oh, okay. It took longer to process than I thought. Things gone wrong here. Okay, let's just read through this again. See where I've gone wrong. I mean, it's a big file, a couple of thousand lines, right? But maybe I need to do group answers plus equals C for C in row. Maybe that makes more sense. This is that. That's better. That's more what I was after, right? So we've got this list of sets now of what everybody was up to, what all these answers are. So then in this example, the sum of these counts. So we want to just do the sum of the length of all of those things, which feels silly. Like I feel like I've managed a lot of the logic. Right, let's just do part one. I mean, if I just do, this is just be another list comprehension, right? If I just do length of answers or answers in groups, that's going to give me a list of those. And then if I just do sum of that like that, it's going to give me that number. That's not the right answer. Your answer is too high. Okay. I've done the wrong thing, which is small relief, I guess. But let's read this again, because that was simpler than I was expecting, and therefore I've probably done it wrong. In this group, there are 6 questions to any unanswered yes. A, B, C, X, Y, Z. Z. Duplicate answers to the same question don't count extra. Each question counts at most once. Another group asks for your help, then another. Eventually you collect all the answers. Yeah. First group contains one person who answered yes to 3 questions, A, B, and C. I mean, maybe I should try this. Let's just have a new file, and we'll call this like sample that we know the answer for, right? I've been kind of skipping these samples until now. Let's just change this to sample for a second. Sample. That gives us the answer of 12. The answer is actually 11. So what's gone wrong here? Ooh. ABC, 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 ABC here. I'm not resetting this. That's what I'm not doing. I'm not resetting that. If I run that, we've got this little A here. And then if I check that, it's 10. There's still something going wrong. Right, ABC. First group should be ABC. Then it should be ABC. It is. And then ABC. It is. Then it should be A. And then it should be B. We're missing a B. Is this might be the same thing I did last time, actually. Let's do that. Once we've finished reading lines, we need to also append the final set. Yeah, there we go. Final set is 11. So let's try changing that to input again. Oh, I probably didn't want to output that. It's a bit long. Then have a look at this answer, 6, 7, 7, 8. That's the right answer. Okay, right. That was not a GPU solution, but that's because this was very easy. So maybe part 2 will be more interesting, because this is what I mean. Like, I feel like most of the logic here was contained in just reading the file. Like, the file reader gave us what we wanted because of our use of set here. If we hadn't called set on this, then we would have had like our list with all these duplicates in, and then maybe we could have done some processing to do that. But I don't know. Set just feels easy to do that. Continue to part 2. Part 2. As you finish the last group's customs declaration, you notice that you've misread one word in the instructions. You don't need to identify the questions to which anyone answered yes. You need to identify the questions to which everyone answered yes. Using exactly the same example as above, The first list represents answers from 5 groups. In the first group, everyone or one person answered yes to number 3. Okay, so it's good. They've broken the sets thing here, I think. So I think this might get a bit harder. In the second group, there is no question to which everyone answered yes. In the third group, there is, yeah, right. Okay, that makes a bit more sense, I guess. Even so, right, I'm going to move the set here out. I'm just going to append some lists onto this, so our input becomes this. Let's just have a look at 10 things here. So even that's quite long. Got 1. Even that's really long. Anyway, I'm happy with that. That's now a list of all of the answers. So if I just call set here, this would also do the same thing. It should also give me 6, 7, 7, 8. Right. Let's call this part 2. So what we want to do now is, oh, we don't know how many people were in each group, do we? Maybe I want to do something like where groups is a list, but group answers is a dictionary. And we will have some counters and things. So let's do group answers plus equals. So this will be group answers for C in row, and we'll also have we'll have count. Let's just call it count equals 0. I might actually set this up. Yeah. No, let's need it there. Count equals 0. I need it there as well. So reset the count like that. So group answers plus equals that, and group count plus equals 1. And then I'm going to change this so we have for answers, it'll be, let's call this group, and then we'll call this group answers. Like that. Group answers. Yeah, that's just me typing bad Python. Error answers. Maybe I need to that as well. Yeah, that makes sense. Okay, so that's giving me the same thing, but now if I look at like groups 0, can I do that? Yeah, we've got count and answers. So now what we want to do is go through each group. We want to say like for, and I might still do this as a, say for group in groups. We want let's have group for grouping groups. And then we want like a list comprehension here that is answer for answer in group answers. We're going to go through, oh, let's go through the set of answers. And then we'll say, I can type. And then we'll say answer. Okay, this is getting more. This is more complicated, which is good. But maybe I do want to think about. No, I'm going to keep going with the CPU solution here, just because I feel like this is kind of Python language stuff that we can do this with like some simple list comprehensions. Oh, I want to. For grouping groups, let's do it as like a not list comprehension. Let's just do it as a regular loop. Before grouping groups, for answer in set answers, if do Python count substring in count item count. Is it duplicates in list? That's what I want. Duplicates in list. Count repeated items in the list. We do this using count. Okay. If group answers, which is a list, isn't it? Yeah, if group answers dot count answer equals group dot, it's group count, isn't it? Group count we want like a new thing, or do we want to modify? What if I can say like group all answer plus equals answer. Let's just try. I'll try that. Except key error. That equals a list of that. Right. And then if we have groups all answered, it'd be like, this would be the same thing then, right? But it'll be that group all answered for grouping groups. Yeah, here are all answered. I might we just have all answered groups is a list. Groups, all answer groups dot append all answer, something like that, and then do this. I'll put another thing in here. Groups dot append thing. And hashable type list. I've done wrong. Group. I don't think I need a set here now, do I? I just want to say group or group in all answer groups. 826. I don't feel like that number should be bigger. My logic's gone a bit funny here. Let's try and think this through. Because I keep modifying my data structure, right? I just want to restart. Let's read my input again and make sure I definitely get that. So we have our count and we have our answers. You know, maybe I should change this around. So instead of appending a list of things, we have our answers is a dictionary instead. Like that. And then our answers, we could just say like 4C in row, group answers C plus equals 1. And then we'll do our try and accept and key error here. So we'll do our accept key error. Here we'll set that equal to 1. That worked. And then this will be answers.keys. Yeah, that gives us the same thing, 6, 7, 7, 8. But now we've got like an even more useful thing to work with. Because we have like these answers and their counts. And then we can do something like for group in groups, group for group in groups, group for group in groups. And then we want answer for answer in group answers. And then we want like length of answer. Just cute. Where am I with this? Group is not defined. Yeah, it's because it needs to be in here. Need to do that, but we're going to go through these and get the length. Then we'll say length of answer is equal to group count. No, but that's not what we want. We don't want length of answer. We want answer. This would be the key. So this would be group answers answer. The mirror is the word answer lost all meaning. And then we want to collapse these lists and count how many trues are in there, don't we? Let's just have this is getting really long because I'm going to need to do something like Python flatten list item for, we could do item for sublist in that for item for sublist in that or item in sublist or item in sublist. I think square bracket, give us all of these, and then Python count true in list. I don't know if true booleans in a Python list is just sum. You can just call sum on this. Okay. This is very unpleasant. I thought I could do this all in a list comprehensions, which 3406. Answer 3406. That's the right answer. Okay. So given the right data structure, you can do this all kind of in Python languagey things. I think what I really should have done for this to be like something we could process on the GPU, reading this in, I reckon I probably want a data frame of like all the columns would be all of the letters of the alphabet. Maybe an array. I'm like almost working backwards to GPUify this now, but if I had all the columns of the alphabet and the group, I still wouldn't have yeah, maybe. But I'm thinking out loud now. I kind of want, I might just, right, I'm gonna call it there, as in I've done day 6. I'm just gonna have a very quick play for maybe 10 minutes to see if I can do this with with like a data frame type thing rather than doing it this way, because this tends to be how my brain works for doing these kind of things, not on the GPU, and I just can't map it over immediately. But let's just try. I'm just going to do a new section here, just called like trying GPU. Yeah. I'm gonna literally copy this, but what I want is our groups is going to be that. Let's just get rid of basically all of this. I think so. I've got count, which is the number of people in the group, and then I've got answers here as a dictionary, but I actually think I will flatten this out. Can I just do like Python range over alphabet? Okay, did not know that. So if I import a string, I can do string.ascii lowercase as a list, which will give us all the letters in the alphabet, and they are all lowercase, aren't they? Yes. Here's a list of all the letters in the alphabet. And then here I want to do count as that, but then I want actually let's do group answers equals a dictionary of letter and 0 for letter in that, right? So this would give us a dictionary like this, where we've got all the letters of the alphabet. And then let's do group answers count equals 0 as well. So we'll have a column count, and that's also going to be 0. 0. Get rid of that. And then we're going to read through the lines. We're going to strip them. If row is that, then we're going to append the group answers to that. That's exactly what we want to do. And we want to do the same thing again here, where we reset this. Don't like that code duplication, but I'm going to do it anyway. And then we're going to do for C in row, we'll do group answers. We don't need this by except because they all exist because we've pre-created them. We're going to do group answers C plus equals 1 and group count plus equals 1, and then groups.append. Okay, so let's try doing that. Key error answers. Yes, we don't need that because it's just C now. We're going to have that, and then let's have a look at groups. Okay, so groups looks like this. We have all the letters of the alphabet with like how many times they answered their question. Now let's import pandas as ED. And we'll do df equals, oh, and we want CuPy as well. Import CuPy. Oh, I haven't got my GPU dashboards open or anything because I restarted before. GPU utilization, GPU memory, just see what's happening. But that, shrink that down. Close that out. So we'll do df equals qdf dot from. Oh, let's go and put a CuPy. I want qdf. qdf dot from pandas, and then we want pd dot data frame of our groups. Have a look at df. Okay, I think that's better. We've got all of our groups. We've got the number of times they answered those questions. In this like data structure on the GPU. So let's just do part 1 again. Part 1, we're going to do like an any or something. We want to drop count for a start. So we want like p1df equals df dot drop. Will drop work again. Drop specific from columns or rows, access is 0. So we want to drop returns a data frame without the removed index or column label. So I want to just drop count from here, don't I? That's what I want to do. Count. have a look at P1DF. We don't care about that. One or more values not found in Act. Like that. Okay. So we've got our part 1 data frame as just the alphabet. And then we want like do like a row wise thing. Let's just do pandas count columns with value or with condition or is it count rows? Pandas count rows with condition. A data frame row count based on. No, we want to do something like where it's going to be, you know, how many of these are above 0. Almost wonder if do as GPU matrix. I wonder, yeah, okay. Maybe I just want to use this for getting our array onto the GPU, because that is a more useful thing. Because this will give us that, I think, if I do if I get the first row of this, we can see, right, yeah, let's rewind a bit. We've got a QDF data frame that we've constructed from our dictionary of things. Data frames are backed by arrays, so we can do as GPU matrix, which will give us like a raw array. Now we can, I think in day 1 I did like here's how to get some data back from the GPU. I think is the copy to host, right? So we do our array.copy to host. Let's come and slice that. So if we do row 0 dot copy to host, autocomplete for me. I'm just going to copy it. I think autocomplete went a bit funny for me then. Say copy to host like that. That's given us a row here, which is, yeah, but it's got the count as well. But yes, this is 1 0 1 4 0 4 etc etc. So we know these are the letters of the alphabet. And then yeah, so we could do let's also come and just copy this from number. Let's get rid of this. I might even here have our like groups array is going to be this GPU matrix. Yeah, groups array, that. And then let's do from number import CUDA. I know this is taking me longer than I thought, and I've kind of, I've got a CPU solution, but I'm really keen to get a GPU solution here. So let's CUDA.jit this. This will be count group answers. We'll take our groups array and we'll give an output array output. And we'll do the same kind of thing, right? So our position is going to be for I in range length of the groups array. And then again, I'm just going to do out, and that's going to be no. What we want there, is it? Let's grab a different. I can. Yeah, right. Position of CUDA.grid. If position is less than the length of that, that's what we want. Then output array position is equal to 1. And then let's do output. I haven't imported numpy either. Import numpy as np is np dot zeros of the length of the groups array. We get this output, right? output array that looks like this full of zeros. Oh, I also need to calculate my threads per block and blocks per grid. The length of that. And then let's call group count answers this. Give it our blocks per grid, our threads per block. We're going to pass in the groups array like that. And then let's have a look at the output afterwards. So that should all just convert to ones on the GPU. So that's good. Then our logic here, we just want to say this is a sum, isn't it? Basically, what we did before. It's just a sum of the set, these things. Although it's the number of columns that's greater than 1, right? So, because output groups array position here, groups array position is going to be like an array of this. So it's going to be A through Z. We actually care about groups array position 0 through -1. We want everything except the count, because the count is not a real thing. And we want to do for answer in that list. We want to just do output position. Yeah, let's do if answer is greater than 0, output position plus equals 1. Okay, that's given us that output. And then if we do sum of output, we get 6778, which was the first answer we got, right? 6778. Okay, so I hope that's kind of clear of what we've done here. We've read in our data kind of as an array of the alphabet now. So we've got A through Z and a count on the end. And you know, I took a step through pandas and QDF just kind of for the data frame niceness and visualization here, but we could have done this reading in here as a different thing. So let's do part 2 as well quickly. Let's go part 2. We want to do basically the same thing, but this is going to be count group all answers. It's the same kind of thing, but we want to say if answer is equal to this -1, right, which was our count, then plus equal 1. And we can do the same thing. So we've got our count group all answers, get a new output here. And then if we do a sum of this, we just tweaked our logic very, very slightly here. We get 3406, which is the same answer we got before. Okay, my brain, this is the first one we've done actually where I've done a CPU solution and then like tried to back it out into a GPU solution. And I think it's because it's the first part that threw me, because I was like, well, our data processing got us to a point. I know our data processing started out simpler than this, but our data processing got us to a point where I can just do I could just use set basically to do the logic here. But then part 2 got more complicated because we're like, oh, I have to mess around with things, and then I ended up writing this horrible list comprehension. And you know, for loops in Python are expensive, and I've got how many for loops in this comprehension? 4. There's 4 nested loops in this comprehension, so this is not going to be the most performant thing. Whereas here, you know, we've had to like think a bit more, taken maybe a slightly unnecessary walk through QDF, but we've had to think about unpacking our data into an array of sorts, and then we've kind of gone through the array and done, you know, some slightly different logic, but it's resulted in much cleaner like calculations. Like there was only a minor difference here to change between the two. I think going through the effort of unpacking the data was really beneficial in this context. So let's leave that. We've done part 2. Yeah, we've done both parts on the GPU now, which I think is much more useful, and given the context of this, it makes me happy. and we got the right answer. So let's go back here and have a look at today. Day 7. This has been a bit of a marathon. We've only been going for an hour and we've done 2 days worth though, so I'm quite pleased. Knocked my microphone there, apologies. So, my brain is aching a little bit. I have pre-read this already this morning as well. It seems a little... I don't know how to approach it, basically, so this might take a little bit more research, but we'll see. We'll see how we go. So, day 7. You land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. All flights are currently delayed due to issues in luggage processing. Due to recent aviation regulations, many rules, your puzzle input, are being enforced about bags and their contents. Bags must be color-coded and must contain specific quantities of other color-coded bags. Apparently, nobody responsible for these regulations considered how long they would take to enforce. For example, consider the following rules. These are quite fun. Yeah, okay. So, light red bags contain 1 bright white bag, 2 muted yellow bags. Dark orange bags contain 1 bright white bags, 4 muted yellow bags. Bright white bags contain 1 shiny gold bag. Okay, so we've got kind of broken down into color. Color seems to always be 2 words. We've got color, bags, contain, and then a list of quantity, other bag or bags, right? So again, we're going to have a bunch of data processing here to do. These rules specify the required contents for 9 bag types. In this example, every faded blue bag is empty. Every vibrant? Did I say violent before? Every vibrant plum bag contains 11 bags. 5 faded blue and 6 dotted black, and so on. You have a shiny gold bag. If you wanted to carry it in at least one of the bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least 1 shiny gold bag? In the above rules, the following options would be available to you. Bright white bag, got kind of written here, can hold your shiny gold bag directly, right? Bright white bags contain 1 shiny gold bag. A muted yellow bag can hold your shiny gold bag directly. So a muted yellow bags contain 2 shiny gold bags and 9 faded blue bags. A dark orange bag, which can hold bright white and a muted yellow, means that either of those could hold your shiny gold bag, right? So you could put your gold one in a white one and then inside an orange one. So orange is a valid like outer container for your gold bag. And a light red bag, which can hold bright white and muted yellow. Okay, so a light red bag can also hold either of those. So in this example, the number of bag colors that can eventually contain at least 1 shiny gold bag is 4. How many bag colors can eventually contain at least 1 shiny gold bag? List of rules is quite long. Oh, I thought the last one had quite a long list of rules. Okay, so let's get out of here and make 07. And let's have a new notebook and rename this. I'm gonna call this 07 solution just to make life a little easier. 07 solution. And I'm just gonna call this input there of 07 solution. And let's give it a nice title as well. So day 7, data processing. I've not been consistent with my this is read input, this is data processing, this is data reading. Oh, 3 different titles for the same section. I'll go through and make these consistent at some point. I'm gonna go like that and then just close out these. I'll probably open a reference one to copy some code in a minute, but let's open that input. Right, make sure you get all of your input. So get your puzzle input. That was less than I thought it was going to be. Thing, all copy, paste, save. Okay, so this is one problem, but with lots of things. So this is basically a description of a graph, right? Like we have our bag colors, which is our vertices on our graph, and it's a directed graph because this bag contains another bag. So like in this example, we have like our light orange bag, and then we have dark maroon, dim maroon, striped green, pale aqua. They're all like 3 points, and there's going to be like a directional arrow to each of those from the light orange. And so we want to put together a graph, basically, like a graph representation of this whole thing, and then we need to I think we need to either start from our gold bag and try and traverse to all points, or we need to start from all points and try and get to the gold bag. I feel like this kind of thing is probably good to do on the GPU, but I don't know how. So I'm just going to close all of my tabs to the right here. I know there's cuGraph, right, which is a library for doing graph analytics. So maybe there is some stuff in here for doing this. I don't hugely often work with graphs, despite being a Dask developer which operates on graphs. Let's have a look. cuGraph supports creation of graph either from cuDF data frame or pandas data frame, and cuGraph supports execution of graph algorithms from different graph objects. Okay, so we can do matrices like this. I mean, yeah, we're going to be nowhere near the millions of edges. I don't know how many edges we're going to have, but I'm curious to see whether we could do this in cuGraph. Structure. Okay, so we have like a graph object. We can do like a from PDF edge list. Initialize a graph from the edge list. Interested to see what that needs to look like. And then there's some traversal functions here. So remove unreachable vertices from the result of these things. Right. There are acronyms I don't understand here, but let's keep going. So filter unreachable. Yeah, maybe that's what we want to do. We want to filter unreachables. We don't care about shortest path and things. Let's try and work out first. I'm gonna go down this route of things, but fully saying my graph theory is maybe weaker than other things that I can do. So let's start with this and say this conversion from other formats. PDF edge list. Okay, return a new graph created from the edge list representation. This function is added for network X compatibility. Function does not support multiple sources or destination columns, but does support renumbering. I wonder whether it also matters that it's directional, right? Like let's have a look at this graph structure again. To directed, to undirected, return a directed representation of the graph. Function sets the type of graph to digraph and returns the directed view. Directed graph for the same nodes and each edge replaced by 2 directed edges. Now I don't want to. Oh, okay. Let's have a look then. Maybe I need to have a look at network X as well. Network X is a Python library for studying graphs and networks. Because it looks like cuGraph here is like a GPU implementation of this. So maybe by learning a bit about this. Okay, so add node. Add nodes from. Also add nodes along with attribute. Okay. Edges, we can add edges. We can add edges here. Examining elements of a graph. Removing, using graph constructors. Users edge nodes, accessing neighbors. Directed graphs. Digraph provides additional methods and properties specific to directed edges. We have out edges, whatever those are. Okay. Allow algorithms to work with both classes. Fine. Some algorithms work only for directed graphs and others are not well defined for directed graphs. You can do two undirected. Analyzing graphs. Drawing graphs. You can draw graphs, that's fun. Right, graph generators, graph operations. There's a gallery, which is always helpful. We want weighted graph, directed graph. Okay. Do we have, I just want to check actually, import network, type anything then, import as, in command mode, that's why. Yeah. Oh yeah, as NX, okay. If you check out the README, you see kind of what my environment is, but I'm using the latest Rapids Docker image, the latest stable Rapids Docker image. So we already have NetworkX, which I guess is because it's a dependency of cugraph. NetworkX compatibility and transition. Oh, import cugraph as CNX. And then you can do the same kind of things. Okay, so import cugraph as CNX. This is fun. I've never looked at cugraph before. I've like been aware of its existence, but this would be interesting to see what we could do here. So this is all about plotting and things, isn't it? But let's try and see what the situation is. So I want to try and find digraph methods. So we can add node, add single node, add edge, u of edge, v of edge, add an edge between u and v. I assume u and v is the edges. E bunch to add weighted edges. I don't want to add weighted edge. I'm just curious to play with this a little bit. So let's play with this for a while. Let's say our graph equals nx.digraph. What did I do? Incoming graph data. Initialize a graph with edges named or graph attributes. This data can be an edge list or a NetworkX graph object if the corresponding optional Python packages, NumPy, etc. Yeah, so I wonder if we need to, let's have like Python edge list. Edge list. Read and write NetworkX graphs as edge lists. A multi-line adjacency list format is used for graphs with nodes that can be meaningfully represented as strings. With an edge list format, simple edge data can be stored, but node or graph data is not. There is no way of representing isolated nodes unless the node has a self-loop edge. That's fine, though. I don't think there will be isolated nodes in there. Python dictionary as data, 1, 2, weight, color, Arbitrary data 127 green. Read list. Parse edge list. Parse lines of an edge list representation into a graph. Parse lines of an edge list representation. Lines, comments, delimiters. Node type is int. Okay. Let's do that. nx.parse edge list lines, and we're gonna have this, but lines will be like I'm just curious, can we do this? Okay, and then G is a graph, right? We can look at g.nodes. We have blue and green and edges. We have a list of blue and green, right? That makes sense. And I assume that edge is directed. What is G? G is a graph. Directed. That added more. Yeah, see, that's added edges. But we don't want the returning edge, right? Yeah, we don't. Yeah, let's make this list. Let's have like red and blue and brown and white. We've got red, green, blue, green, red, brown, and white. We've got all those edges there, right? Which are those three edges we specified. Look at network X to directed. As view. Multi-graphics, add edge 0 and 1, g.to directed. I also wonder if I could do something like graph equals nx.digraph, and then we'll do graph dot add edge, add blue green, right, as an edge here. Missing one positional v of edge. Oh, is it like that? And then what does graph look like? Graph nodes. Okay, so we have blue and green, and we have edges like that. Okay, we have an okay. I think we want to do something like this. We've got graph equals that, and then we want to read our input. Let's do this. So for with open input as file handle. Let's just have let's call it rules again. We'll just do fh.read lines. Read lines. Let's make this a list for now. Let's do rules equals line for line in read lines, and we'll do line dot strip just to make it nice and clean. Strip that. And we should have rules. Looks just like that. Fine. So now we need to do for rule in rules. We need to process these. So let's let's just get rule equals rule 0 so we can have a look at it. Like this rule. So we need to split somehow, don't we? We want to split on the word contain. Contain. And probably like that, right? We'll split on the word contain. And we'll end up with start bag and edges, something like that, right? Start and edges. We start, we want to do dot replace bags with nothing. Right, so we end up with light orange. That's what we want. So let's for rule in rules, let's replace that. So we end up with start equals that. And then we also have edges. Looks like this. So we need to do edges dot split. Actually, I want to do edges dot replace the dot just to with nothing. Actually, edges dot replace, and then we'll do a split on a comma space. Split on a comma space. End up with this, and then I want to do like a replace bags with nothing, and replace bag with nothing, and we want spaces for those. So doing that. Oh yeah, we're going to replace that. This is now a list. We have edge for edge in that, and we'll do replace those things. We end up with 1 dark moon, 3 dim moon, 5 strike green, 2 pale aqua. So maybe we want to, like, these are weights and things, right? So we need to do weight and node for weight and node in this is another list comprehension here. Oh, this is getting unpleasant. In that dot split actually let's split on I want to get everything up to the first space, don't I? Python split string on first instance of, oh yeah, on first space. Okay, I do that. So we do split space 1. That, and then it will be int of weight. Valid syntax. Miss something. Weight node for weight node in. That need to be like a tuple? No. Edge node in replace. We're getting a bit gnarly. Let's start again. Say edge for edge in that, right? And we'll call this let's call this edges as well. Edges equals this. So like unpack this a little bit. So we've got edges equals that. So edges. Yeah, that's fine. That's cleaned that up nicely. And then we wanted to do edges. We'll do edge for edge in edges again. Edge in edges. These words lose meaning when you end up typing them so much. But edge for edge in edges. Then we'll do edge dot split on a space once. We'll end up with that. Okay, so we've got like these lists here. Maybe I'll actually put that in there, so we'll end up with this. Let's do this again. That equals that, and then edges equals that, and then edges now looks like that, and then we want to do something like, let's just do edge for edge and edges again. Edge for edge and edges. Edge, edges, we get this. We want to do edge. And now let's try calling it, can I unpack the two things? So if we do weight and node and put those in a tuple, weight and node, and make that an integer. Okay, that worked. And then we want node dot replace to Python replace two things. Multiple substrings, can you do that without using a regular expression? Nope. Okay, let's just do it. Let's just do two. We just have bags and bags. Replace that with nothing, and then replace bag with nothing. Okay, so we then end up with this: 1 dark maroon, 3 dim maroon, 5 stripe green, 2 pale aqua. That's going to give us new, even more edges, that, and then actually it's going to be start. Let's call it start, end, and the weight. Ooh. Like that, right? I'm gonna do these. Yeah. So edges now is equal to light orange to dark maroon with a weight of 1, light orange to dim maroon with a weight of 3, etc., etc. Okay, so that worked. So now that we've got that, I want to do for edge in edges and add them to my graph, right? So add edge. Correct. Did graph the reference. Graph types. Tutorial. And that was the reference. Reference, graph types, digraph methods, add edge, attra. Okay. Add edge, here we go, weights. I could do graph.add edge, and this will be start, stop, weight in edges. We'll have start, stop, and then weight equals weight, like that. So if we read the data in, invalid, okay, that's a shame. Let's just try that. I just want to see what the line is. Accept value error as E, print rule phrase E. Oh yeah. Right, fuchsia bags contain no other bags. Okay, so we've got another case here. It's not in the graph, so I don't care. Let's just say, let's get rid of that and rid of that and go like that, and then just say if contain no other bags in rule Continue. Lovely. So now I should have a graph. Do graph dot nodes. We've got loads of colors in our graph, and we have edges kind of telling us where they all are. Right, so then what we want to do is we want to functions have we got? Drawing could be fun. Draw the graph G. I'm tempted to go to they had a gallery, right? And there was directed graph. We have draw edges. Seems complicated. I want just like a plot function. That's what I want, to just draw it. Simple path. Right, we've got a graph. nx.draw g plot.show. I'm just curious to see what happens, basically. Just not done this before. There's import matplotlib. And then let's just do nx.draw. I mean, we probably want to do matplotlib inline, just to make sure it appears in our notebook. That will be nx.draw graph plot.show. Ooh, I don't know what's going on. Maybe that's too. Oh, lovely. Okay. Right, we drew a graph. That's fun. It's not particularly helpful. I'm sure there's better ways of drawing these things, as the gallery shows. Edge color map. I don't really want to be messing around with this. Options, node color, edge color is colors. I don't, yeah. I was just curious to see what would happen. I don't want a complex drawing thing. I just want to be able to say draw my thing, and I can't, so it doesn't matter. Right, but then I should be able to do something like I'm going to move it to the GPU now. Now that I have a graph, let's try moving it over. So references. Graph API reference. Version from other formats. QDF edge list. On that. I'm curious to see if I can just do let's just do like C graph equals well, I'm just curious to see if I can do cnx.digraph of graph. Nope. Graph can be initialized using multigraph, and digraph can be initialized using multi-digraph. Digraph? What does that do? Network X multi-digraph. Directed graphs with self loops and parallel edges. Maybe I just want to do that here instead. That's important. I don't want to plot it again. There's definitely a, what is the type of that now? Type of that is a multi-digraph. A digraph can be initialized using multi-digraph. Do I have to do that? Nope. Module cugraph, yeah. There's no attribute multi-diagram. Cugraph from network X. Okay, this blog post is from 2nd of October. Okay, they only added digraphs on 2nd of October. Let's keep going. Cugraph. Graph. QDF edge list from QDF edge as edge in degree. I'm just reading here. View edge list, view transpose. I mean, I guess in utilities, right, there was a traversal. Finds the distance. Breadfast. Go to unreachable. Remove unreachable vertices. Results of SSP. Just say network X directed unreachable. I feel like I'm going along these lines of I've got this. Let's get rid of that for a second. I've got my graph. I might just turn that back into a regular digraph again. What multi-digraph did. I read my input in and generated a graph with network X. Now I want some like algorithms or something. Not sure what these do. About reference functions. So many algorithms, but I don't know what I want. Communicability? That sounds communicability between all pairs of nodes in G. About connectivity. Flow-based connectivity. Returns node connectivity for a graph. No, I want to. I want like a directed graph, find all paths, or find all connected nodes, find all unreachable nodes. Reachable nodes are. This is a different thing, right? One straightforward solution to a BFS traversal for every node present in a set and then find all the unreachable nodes. Breadth first search. Okay. Breadth first search or for a graph is similar to breadth first traversal of a tree. The only catch here is unlike trees, graphs may contain cycles who may come to the same node again. To avoid processing the same node more than once, we use a Boolean visited array. simplicity, this is assumed that all vertices are reachable from the starting vertex. Okay. Breadth first search. Start. Okay, so what does this give us? It gives us find the distances and predecessors for a breadth first traversal of a graph. Who graph descriptor is a graph. Let's just have a look in here then at reference algorithms. BFS, isn't it? What if I just search BFS in traversal edge BFS? Okay, X algorithms traversal BFS. Returns an iterator of successors. Breadth first search from predecessors. Is it this? Predecessor. Returns an iterator of predecessors. Breadth first search. Was I want like a depth limit int optional. Okay. What if I do this? Do network x dot BFS predecessors of our graph, and source is gold bag, isn't it? Gold, shiny gold. And we don't want a depth limit, so our source is shiny gold, and that's a generator. So can I do a list on that? Okay. Good orange. Yeah, I think this has done what we want. So we now want like we want bag nothing for we want bag for bag nothing in that list. Should give us all the predecessor bags for bag nothing in that list. And then we want make that unique, I think. I don't know if there'll be duplicates in here, but Python list drop duplicates. Probably with a set, right? Yeah, I just want to do a set on that list. Set. Like that. Okay, and what was the question? How many bag colors can eventually hold all of it? So if I do length of that, gives us 33. Is 33 the right answer? That's not the right answer. That's a shame. What if I want successors instead of predecessors? Successors? 15. I doubt it's going to be this, but let's try again. I'm slightly flailing. Oh, you gave an answer too recently. You have to wait 30 seconds. Fine. Iterate over edges in breadth first search. So just Google this again. So I want to read more about this. Breadth first search is an algorithm for traversing or searching tree or graph data structures. It starts at the tree root or some arbitrary node of a graph, sometimes referred to as a search key. It explores all the other neighbor nodes at the present depth prior to moving on to those at the next depth level. It uses the opposite strategy of depth first search, which instead explores the node branch as far as possible before being forced to backtrack and expand to other nodes. BFS is an application of finding connected components of graphs. Yeah, that's kind of what I want, right? That's a dictionary of predecessors and a depth first. I mean, there's depth first as well. That was 15. Let's just see what that output is. I'm confused. Why can I not do that? Bag for bag in list of that. Too many values to unpack. Expected to. Do a set on that. A length. 33. 33, not what I tried before. Yeah. Okay. Because the way that I've done this is that our start bag. Oh. Yeah, maybe it is 15 then. 15. Submit. That's not the right answer. Nope. Okay. Okay. Let's think about this some more. So we have our graph. Our input here. We're reading through all of this and we're building up our graph. That plot is not helpful. But we end up with start is our, no, it is, okay, so light orange bags here. Like faded purple bags contain, which is what we're splitting on, contain no other bags. Let's try their very simple input as well. This is what we did before. Let's do a new file and we'll call this sample.txt. Sample. And just try reading in the sample and see what happens. So we'll read the lines in, but from sample this time. All right, and then let's have a look at our graph. Graph. We have graph of nodes, right? Tutorial. Edges. Let's do edges. Graph dot edges. Oh, I've turned this into a raw cell. That's why this is graph edges, right? And graph nodes. Right. So in our input example, we had light red with one white bag and muted yellow and dark orange and shiny gold and etc, etc. So we've got all of our nodes and we've got all of our edges. So now if I try doing breadth first search, we get 4, and do a depth first search, we get 4, which is what this example said, right? That is kind of what I was expecting to happen. Okay. I think that's what I want. We want the predecessors to that bag in the graph, which says 4. And let's just have a look at this predecessors. Oh yeah, let's make it a list. These predecessors. Dark olive. let's just have a look at graph.edges. Light red, one bright white. Light red, muted yellow. Light red, bright white, light red, muted yellow. All right, and then we have bright white, shiny gold. Bright white, shiny gold. Dark orange. Dark orange anyway. Dark orange, muted yellow. Shiny gold, dark olive. Shiny gold, dark olive. Is this because I'm going forwards, not backwards? Shiny gold can contain 1 dark olive bag, 2 vibrant plums. Okay, let's change this to successes then. FS successes. That says 2. Oh yeah. Okay, so successors to shiny gold is dark olive and vibrant plum. Predecessors. Neither of those are giving me what I was expecting, which is where we've got muted yellow, shiny gold, right? Maybe I need to like flip the start and stop route. Oh, I'm gonna put that up in here and just say graph equals bright white, light red, muted yellow. So have a look at these edges now. Bright white, light red. Let's have a look at predecessors. 4 predecessors. 4 predecessors. Bright white, shiny gold, muted yellow, shiny gold, light red, dark orange. Those were the answers here, right? Bright white, muted yellow, dark orange, bright. Yes. Okay. Okay. I've got the right answer out here. The last thing I just need to do to make this all GPUified is use cuGraph instead of NetworkX. And I don't know. I assume I can just do that. I do wonder if I can just say, I'm just curious to see if I can go like that. Restart. Digraph has no attribute add edge. That's disappointing. NetworkX digraph. Right. NetworkX compatibility and transition. Use NetworkX graph objects. Okay, so import NetworkX, create a random graph, NetworkX. Oh, you can just use, can I just do this? DNX, that? No, cuGraph has no attribute BFS predecessor. But yes, that does seem to be the idea, right? All algorithms in cuGraph support a NetworkX graph object as input and match the NetworkX API list of arguments. Currently, cuGraph accepts both NetworkX graphs and digraph objects. Okay, it's just that the reference here is missing. I'm just curious what happens if I do a DNX. DNX.bfs. DNX.bfs on graph or shiny gold. What does that give me? cuGraph. Oh yeah. CNX. Digraph has no attribute renumbered. Right. Find the distance. Edges reachable. Compute the distance of predecessors. Oh, okay. What's this? Right, if I go like that, DNX. First order SSP, graph and shiny gold. Function object has no attribute SSP. Attribute error. Digraph object has no attribute renumbered. Network X digraph. Relabel nodes. Okay. I've got this. Let's change this to input dot text. I'm just gonna. Oh, I don't really want to look at these like this. Let's just have a look at the length of network X predecessor. 148. 48. That's the right answer. Okay. This is. I haven't done this in GPU yet. I've done this in the CPU with network X. But we've done a breadth first search to work that out. So continue to part 2. Part 2 is getting. Let's not worry about GPUs right for this second. We can always come back to it if time allows. I'm actually running out of time. I'm at 2 hours now, which is kind of what I'd allocated for trying to do 3 in one go. So, but yes, I want to. This could be one of these things where these functions just don't exist. I'm just going to get rid of that. So we've got BFS predecessors like that. And then let's have a look at the next part of the problem. So it's getting pretty expensive to fly these days, not because of ticket prices, but because of the ridiculous number of bags you need to buy. Consider again your shiny gold bag and the rules from the above example. Faded blue bags contain 0 other bags. Dotted bags contain 0 other bags. Vibrant plum contains 11 other bags. 5 faded blue bags and 6 dotted bags. Dark olive bags contain 7 other bags. 3 faded blue bags and 4 dotted black bags. A single shiny gold bag must contain 1 olive bag and the 7 within it, plus the 2 vibrant plum bags and the 11 bags within each of those, so you end up with 32 bags. Of course, the actual rules have a small chance of going several levels deeper. In this example, to be sure to count all the bags. Okay. Here's another example. In this example, a single shiny gold bag must contain 126 other bags. How many individual bags are required inside your shiny gold bag? Okay, so we need to reverse the graph and add all of its weights together. Yeah. I think that's what I want to do. Oh, I don't know actually. No, this is more complicated. I think what I'm going to do, I'm going to call it a day because it's been 2 hours. And I might revisit this. It depends how, I guess it depends how hard tomorrow is, but I might revisit this at the beginning of the next session. So I'm going to stop here and I'm going to come back to it. Thank you very much for watching. I hope this has been interesting, and I will see you next time.